Thank you, Jim, and glad to be with everyone this afternoon. And I guess, if we could simplify kind of what we're trying to get at today with this presentation, it's really how do we better use data for real-time operations? This is a big topic, not only here in State Highway at MDOT, but obviously with our EDC6 initiatives and everything, we're really trying to figure out how, from an operational standpoint, we can be a little bit less reactive and a little bit more proactive in how we're making some decisions. And when we talk about what some of those decisions are, you can go to the next slide, Kevin. The business need here, there are obviously some tactical decisions that happen on an incident scene like the one you see there to your right. But when we talk about mitigating the impact of an incident and how we can alert motorists and take a more, again, proactive stance there, do I need to call in additional resources for a lane closure? How far back should I be messaging on my overhead message signs? Do I need to notify up my chain of command? When are we going to post on social media and any other outlet that we're going to notify the public? And again, are there other types of notifications I need to make? Are there other adjustments maybe to signal timing or other TISMO systems that I need to interact with, and when do I do that? And when we really look at when we're going to do that on the next slide, we look at incident duration and we look at the incident impact. And by incident impact, I mean the queue length on the primary roadway and then the potential for the spillover on the secondary roadways. To the right, what you'll see is in Maryland, we call them FITM plans, freeway incident traffic management plans. In your state, you might call them something different, but the concept being that we've done some engineering work and operational conversations, forums with our local partners to figure out if the roadway is closed between a certain segment, where are we going to send traffic? We've looked at bridge clearance heights, any weird turnabouts or anything that might prevent a commercial vehicle from being able to make a turn. But the problem is that all of these plans are built on a full roadway closure, or we're going to have a lot of equipment out there. We're going to have shop resources from our maintenance teams, full attenuated trucks, detour signs, and the gamut to move traffic as efficiently as we can. But there's a problem. Next slide. We know that the public is not waiting for a full roadway closure before they make their decisions. The screenshot you see below is a screenshot from the Waze traffic view tool. And for those that might not be familiar with it, which is available through the Waze through Cities partnership, what I like about it is you can build your travel routes, and then along that segment, if there's a major delay that Waze would reroute people, the purple line that hopefully you can see there on your screen is where Waze along that segment would be routing traffic. So we can kind of see what they're doing. The roadway was not closed for an incident in this case. There was just heavy congestion, and Waze was saying, I'm going to send motorists a different way. So when it comes back to making our decisions, is there a way for us to have better data to make some of those tactical decisions from the TMC or anything that would look at the impact, right? Should I be detouring traffic at an earlier point? Where are they going? Should I be adjusting signals? How can I do that? But what if? Next slide. What if we could do that? So this is a screen from our current ATMS system, which calculates the current queue using probe vehicle data. The operator could enter their own number if they had it from a different source. And there's also a place for us to estimate the hours to clear. And right now, that's a very manual process. We're talking to responders on the scene and getting their input, and they're using their experience and conversation with fire and police responders on the scene to figure out how long do we think this is going to be. And it's exactly what you think. Well, the tow company's telling us it's going to be about an hour for them to get there. Investigation is going to take a half an hour, and then it's probably going to take us about another half an hour. So we're at 2.5 hours before we can get a lane open or get the roadway open. So we realize there's got to be a better way, right? There's got to be a better way to crunch something. We're just going to keep relying on boots on the ground, and that's fine. But we probably have the same problem you do in your agencies, and that's turnover. So that's great to rely on that experience until that experience is not who's there, and you've got a lot of new team members that might not know from their experience, because they have no experience, how this is going to go. So we realized, next slide, we have data going back to 2001, at least here in our chart program. And data always tells a story. We all know that. So simple on this chart, right? What story is this data telling me? If I look at the middle of this chart and I look at the congestion events, we call them. So this is the number of times an operator opened an event for the purpose of putting congestion messages out on the overhead signs. We can see that that starts to drop considerably in the 2008 year, and then to the point in 2020, we didn't do it at all. What story is that? Well, that's about the time we started implementing travel time on our overhead message signs. So we did not activate those overhead message signs because we were relying on probe data to automatically generate those messages, and to the point that now it's so institutionalized that that's what we rely on solely, unless it's an incident message up for a crash. Along with the bare bones data we're collecting, like all TMCs, we're recording a lot of data on what lanes are blocked, who's there, timeframes of all this. Can we mine it? So what we did is we reached out to the University of Maryland's Civil Engineering School on several research projects to try to do just that. Next slide. So phase one, we said, well, let's just do a test corridor. Let's just look at whatever we think the highest incident volume corridor would be. We picked Maryland's I-95 corridor. For those that aren't familiar, it goes from the Maryland-Virginia line all the way up to Delaware. And it's not just Maryland State Highway that operates some of that, it's also the Maryland Transportation Authority. Luckily, we share the same ATMS, so we have all the same data. And so we asked the University of Maryland to see, can you calculate the event duration probability based on our ATMS data, not using any crash reports from the police, but using solely our ATMS data. And they found through their first phase that they could, with about 85 to 90% confidence on that corridor. Then we expanded to include our 495 Capitol Beltway around Washington, D.C., our 695 Beltway around Baltimore, and then our I-70 corridor, which connects our far western Maryland, where it connects to the PA Turnpike, to that Baltimore Beltway area. And similar results, around that 85, 80% confidence score. And then the third phase, we said, well, this is great, but if we're going to institutionalize this, we can't have it necessarily be by particular roadway. It really needs to be either by roadway class or clusters of roadways. How do we make it network-wide, roadway network-wide? And so that was the third phase, which we are just finishing up right now as we speak. But along with that was the second piece, which is not just how long is the incident going to last, but can we predict the duration of that incident along with the queue? And again, we found that we're pretty sure that we can do that pretty accurately. Next slide. How do they go about doing that? Well, first they look at what are some of the common data elements within our TMC data that really were telling as to how long this incident would last. And you can see them listed there. Number of responders and who's there exactly. First responder on scene, was it the fire department, the police, was it our chart program, our SSP TIM unit? The vehicle status, overturned, did it lose its load? What really is that vehicle? How is it situated on the roadway? Wet, dry, snowy, pavement conditions, lane blockages, what number of lanes are blocked, what operations center is handling it, and then the time that the time of day that the incident is occurring. Next slide. And then they looked at what elements are the most transferable. So what mattered the most as far as incident to incident? What could we say were common factors, or the most common factors in telling how long this is going to last? I found it interesting from an operations perspective that the number one criteria was the number of responders, not the vehicle status or the number of lanes taken, which is what I would have thought was. But when I thought about it, and when you dive deeper, number of responders can be a clear indicator of how complex that incident is. That we have an overturned tanker with fuel leaking. I'm going to need a lot more responders than I'm going to need for that single property damage crash. So that was pretty revealing that it wasn't related primarily to the status of the vehicle. I thought overturned or lost load or something would be the highest indicator, but that was not the case. And I know it's hard to see on this graph, but if you look at the orange bar, that's the highest of that subset. So just taking the number of responders, the total number, regardless of the type, if you will, on that is the highest indicator. But then there's number of SSP chart units as the second largest factor, number of tow services on scene, and you can keep going down. So this presentation will be available to you afterwards. You can drill down and kind of look at some of those other factors. But after that, we did another test set. So this is, again, phase 3. We're trying to expand to the other roadway systems. Next slide. And we looked at whether or not we had the same success rate. So this was looking at all the incidents along I-70 as part of this phase 3 set. We trained the data model, well, not we, University of Maryland, trained the data set to our 2016 and 2018 TMC data. And you can see what it predicted there. When we ran it against the 2019 data, you can see pretty successful, still in that 80% range. And you tell me in operations that I've got an 80% chance of being right, I'm probably going to pull the trigger on that decision. So next was, okay, we have this data, we think we can do it. How do we get it into the operator's hands to start making some decisions, on this? So they created a tool for us. Next slide. And right now, this is a standalone tool that the operator would have to use, separate from the ATMS. And there is a slight problem with that, and that's that they're going to have to input some of the data they were already inputting in the ATMS. And we'll walk through that here in a second. So you have the option to either start with the incident clearance time prediction, or you can jump right to the queue. There's a reason for that, and we'll talk about that in a second. Next slide. So first, the operator starts putting in all the data we have. So what number of lanes are closed, what roadway is it on, what's the vehicle count involved, what's the status of the vehicle, overturn, lost load, etc., what responders are on scene, and who was the first on scene. Next slide. And then after that, it will spit out a calculation based on all that data. So in this case, you can see that it's estimating an average clearance time of 45 minutes. And that's what we would use as our decision point. 45 minutes is what we're hearing this incident's going to last. So for example, in Maryland, we don't call out a full maintenance shop after hours unless it's going to be at least a hour and a half, 2-hour closure. So 45 minutes, I'm not going to notify maintenance shops about it after hours. Our chart units will handle it on their own. But what I also like is you can see the ranges. So 60% of incidents that match this criteria will clear within 10-30 minutes, 70% within 10-35 minutes, and the large majority, 80% of them, will clear between 5 and 50 minutes. So again, even though your median is 45, it's unlikely that it's going to last past 50 minutes. But now I got to figure out, okay, so I know I'm not going to call resources, or I don't need more resources from home, but now I got to worry about managing the traffic management side of it. What is the impact of this incident to the roadway system? How far back is my delay going to get? Where can I predict people will start detouring off? Next slide. We again can jump right from that screen to the queue prediction. And you can either use real-time detector data if you have it, or if you don't have real-time detector data, you can use archive data. Next slide. And depending on what you pick, again, with that out real time, you can use counts, AADT, or you could use real-time speed. Next slide. So 3 shots here. It might be hard to see. If you're using the real-time detector data, you will put in the current flow rate of an upstream segment from the incident, and then the incident duration that you had previously calculated. Or the reason why you could jump right to that queue is if we know that there's a corridor, and we haven't found this yet, but if we know there's a corridor that is very, very low, it's not that 80%, it's always going to fall maybe in that 60% reliability, and there's something that for this incident, you trust your responder on scene, that estimate, more than you do that data. For whatever reason, you can use your own estimate here. So you could type in whatever your estimated duration of that incident is here. Total number of open lanes, total number of blocked lanes, real-time detector data, you put your vehicles per hour, and then for the speed, you'd put your current upstream speeds, and then, is it greater than 800 vehicles per hour roadway or not? Next slide. And it will spit out for you the estimated Q. And again, your percentage is there of the likelihood that it'll reach that particular Q duration, Q length. And for this particular incident, it was not a real one. I was doing a test incident, but this was that same 45-minute duration that I showed a moment ago, and I used speed, not average counts, just because from an operator standpoint, that is easier for them to see. We have some detectors, but we also have the probe data we can use. There is a link though inside the tool. That was on a previous slide. I failed to point out that you could click the link to get to State Highways record of data for the average counts for that if you wanted to use that. But the operators tend to use this just because they can more easily see this right from the ATMS and transfer the data over. So what are we really trying to get at here? What does this do for the operator? Next slide. So what we decided to do for the operator, I think I'm gonna be missing, was there a slide? Forget. So there's a slide missing. So what would happen here in the ATMS is the operator would see what we are calling an incident severity score. So this is a mean average calculated behind the scenes where we've given a weight, if you will, to different factors of the event. What roadway is it on? What time of day is it? And part of that is, yep, it's calculating through some of the same data, that incident duration. So after they see that incident duration, it calculates it, the operator will get a severity score, and at a certain point, if the severity score reaches above a certain number, the operator gets a pop-up, gets an alert that tells them, we think this has reached the level where you need to take further action, you need to retime signals, you need to consider opening your PTSU if you have one, based on that data. It goes back to that change of mindset. And we're still calling it a FHWA plan. It says we think you can execute this FHWA plan, but FHWA plans no longer mean a total roadway closure. A FHWA plan is any way to manage traffic along that freeway. So the idea is to give a decision support tool to the operator that is data-based. And again, phase 4, if you will be to automate this inside the ATMS. So the operator is not going to be bouncing back and forth between systems, and that pop-up will be more, I'll say, real time. The operator doesn't have to wait for the operator to put in that calculation. So with that, that's a quick overview of how we're trying to use data from our ATMS and our TMC to improve our decision making and real-time operations. Jim?
Jason, wonderful. Can't say enough great things about Maryland. You guys have always been a leader. You're still a leader, and these tools for those. Well, quick question for you, Jason. The dashboard piece of this, or in general, how much of this is public facing?
Great question. So none of it yet. So it's not proprietary, but we don't publish it quite yet. We have discussed, Jim, putting that estimated duration to our website as one of our published fields, so the public can see what we're estimating it's going to be. The only concern with it, in full transparency and discussion among my peers here, is that the public latches onto it. We'd have to do some education that number could change through the course of the event, right? So as those factors are being inputted, that number will go up and down. So it's a snapshot in time for when that motorist looks at that website, hopefully before they're departing their house and not looking at a website while they're driving.
Yeah. And earlier today, we were on a call with Florida Next Gen Tim, EDC 6 Next Gen Tim call with Florida, and we had some similar discussion about their dashboard and technology data tools that they use. And in your case in Maryland is I guess the secretary is well aware of this, your transportation secretary, but is the governor aware?
The governor is not aware of these predictive tools. No, he is aware of the general concept of taking a more proactive approach, and the statewide operations center here of one of our 4 traffic management centers being more interactive and active traffic management of the signal system in particular, but all these other TISMO active traffic management systems we're putting out, but not the nitty gritty here of how we're doing it.
Yeah, no, I understand. Well, regardless, Jason, kudos to you and the team. We really appreciate all your work you're doing, and it just underscores having data and justifying everything through data-driven analysis, like what you've done here, is just where all states should go eventually. And Paul, Joe, and I and our team, as you guys know, through EDC4, crowdsourcing, and even now with EDC6, trying to promote the data collection and data, but most importantly, the use of the data to show benefits, et cetera. So thanks again, Jason.